The next structure that we're going to talk about today, this is part 3, incidentally, of January 30th, 2014's video pre-lecture for CIST 1400, section 008. The next structure that we're going to talk about is the switch statement, which basically is a new way of writing if-else statements. So let's revisit the drinks menu example from last lecture, which we programmed using if, else, if, and else blocks. And it looks something like this. Right, so we collect a choice from the user, we store that in an integer called choice. If it is equal to 1, we do water. If it's equal to 2, we print juice. If it's equal to 3, we print milk. And otherwise, we print out it's an invalid choice. So in this case, we have a single choice with multiple options, and all of these options are discrete. Let's say they're separate. They're not ranges, they're just like selections from a menu or something like that. And when we have a structure like this, a lot of the time we can simplify our work just a little bit, or at least rewrite our work just a little bit using the switch statement, which is also sometimes easier to read and perhaps a little bit more transparent in intent. And so what the switch statement looks like is this. Okay, so you have the word switch, the variable that we're comparing it to, and then the, in this case, 3 or really 4 different possible outcomes, as well as what we're doing for each of these. Okay, so we start by declaring the switch statement using switch, lowercase, and then in parentheses, the variable that we're switching on, the variable that we're looking at. In this case, it's choice. This is just like the if statement that we saw before. And then an opening curly brace. This is a switch block. The variable we're evaluating, which in this case is an integer, but it could also be a character or a string, goes inside those parentheses. And when we say something like case 1, this is equivalent to saying if choice is equal to 1. And the thing that I want you to note here, first I want you to note that that's equivalent. It's an equivalent structure if we're using like an else-ifs block. The other thing I want you to note is this colon right here. It's not a semicolon, it's a regular colon. And the reason that that's the case is because it's a special type of label, which we're not going to talk about at all this semester, but it's a thing that if you choose to become a professional Java developer, you probably should know about. Now let's say that our choice is 1. If that's the case, we execute these commands. We execute the things that happen right after the case. So we do some output, that system.println, you got water, and then we break. And all the break does is it basically says, go to the end of the block. Remember that blocks are created by matched curly braces. Here's the start of the block, then here's the end of the block that you can't see it below this little navigation bar. What the break says is, now that we're done, jump all the way down, skip the rest of this stuff. In an if-else statement, you end your code block with curly braces, and that's how you roll from there. With the switch, though, we're going to skip a lot of those curly braces. Notice how we only have this one set. But the trade-off there is that we have to make sure that we use break statements. Okay? If our choice isn't 1, we skip this stuff, and then we move on to our next case, in this case, case 2. So we check to see if our case is 2. If it is, we do the stuff, then we jump to the end. If it's not, we check the next case, which would be case 3. And if it's not that one, we head down to the default case, which isn't required, which is to say that your program will compile without a default case. It'll compile, it'll run, that'll all be fine. It's just good practice. And so if none of our cases get caught, we can think of this almost as a filter, right? We're checking to see if it's 1. If it is, we do the thing and do down to the end. We check to see if it's 2. If it is, we do the thing to get down to the end. If that's not the case, we check to see if it's a 3. The default catches everything else. And by convention, we put the default at the very, very end of our switch, so we don't need a break at the end of that, because then we just skip down a single line. But you can put your default really wherever you want. You just have to make sure that you're really careful about how you break. So let's say that when we prompt the user for a choice, our user enters a 5, which we know is an invalid input. Okay? So the first thing we do is we check to see if it's a 1. It's not, so we move on. We check to see if it's 2. It's not that either, so we move on. We check to see if it's a 3, and it's not that either, so we move on again. Then we hit the default. Okay? And that's how the switch statement ends up working. So we execute the default case where we do system.println not a valid drink, and then we roll from there. If we want to, we can write our case statements without parentheses. We can take these parentheses around our 1, a 2, and our 3, and we can get rid of them. I'll suggest that you use parentheses as it makes your code a little bit easier to read, but you can get rid of them if you want. So you can do something like this, where it's case 1, case 2, case 3, no parentheses, and this one works exactly the same as that one. It's just you've got a fewer sets of parentheses. Now let's say you can use switches with characters and with strings. So let's say that we want to use it as a character. If we do it that way, then instead of numbers here, we put these characters just in single quotes. Remember, our numbers, if we're treating them as numbers, they don't have quotation marks of any type around them. Our characters, though, we put single quotes around them to show that it's a single letter. So we might have something like case W, you got water, case J, remember we're collecting a character, that's choice, we've changed its data type for the purpose of our example. We get juice, case M, we get milk, and default, not a valid drink. Not a valid drink. We could also, if we felt so inclined, use strings as our switch variable. We can do that as of Java 7. And again, these parentheses right here in these cases are totally optional. The thing that you absolutely have to have, though, with these parentheses is parentheses around the variable that you're switching on. And if we use strings, we just put our string literals in here just like you would expect anywhere else. That is to say, we put double quotes around them. So if the user types water, you got water. If the user types juice, you got juice. If the user types milk, we got milk. And that's all good. That's definitely all good. Now, switch statements are only able to evaluate integers or integer types, characters, and strings. They're not able to mess with floating point values, they're not able to mess with doubles, and they're not able to mess with booleans or objects or anything like that unless the object has a two-string representation. That's the thing that we're not going to talk about until mid to late April. As it is right now, though, switch statements can only evaluate integers, characters, and then as of Java 7, which is only about a year and a half old, the string class. What switch statements can't do, they can't test floating point numbers, anything with a decimal, and they also can't test ranges. So we can't test to see if a number is more than some value or less than some value. We can only see if it is equal to that value. So something like case x is less than 27, where x is the thing that we're switching on, that's not going to work. If you want to do something like this, you'll have to use if statements. The last thing to be aware of is if you forget or omit your break statements, Java will perform the actions for the select case and for every case below it, including the default, until it either ends out the code block or it does the break statements. We'll show you all of these things here in just a second. We can combine case statements and also show you what that looks like here in a second. And then finally, and here in a second we'll talk about why the switch structure is useful. So here's our switch demo. Okay? So we've got three variations, one using integers, one using characters, and one using strings. Our first variation uses integers. So we'll show the user a menu, we'll ask them their choice, and then we'll save that choice as an integer. And this is what our switch looks like. This is going to look almost exactly like, or rather exactly like, what we saw before. Things to note, since these are integers, we don't put these numbers in quotation marks or in single quotes or anything like that. We just leave them as numbers. The other thing to note is that we have this break statement all the way through. Okay? Our second variation is the characters. So we collect our characters using the .next, .chart0 methods. We'll store that as letter. And then since that's the thing we're comparing, we use the switch. And this is how you can combine cases, right? This case lowercase w or uppercase w, and either of these cases we do some output. And the way that Java sees this, it says, it's not a lowercase w, I wonder if it's an uppercase w. And then as soon as we hit this, even if it is a lowercase w, we go until we find a break, or until you find the end of the code block. Java skips over, once one of these cases activates, it skips over and ignores all these other cases, it just sees them as labels. But this is how the characters work. And the big thing to note with the characters is just that we have these single quotes around each of them. That's the big thing to note. We don't need the parentheses that are next to our cases. We don't have to have them. That's a relatively recent change. But we probably should, as it makes our code a little bit more readable. The third variation that I want you to see is the string variation. So we collect a string, stored as Word. We put the name of the variable that we're looking at inside these parentheses. And in this case, we check to see if the user inputs water, if they input juice, if they input milk, or if they input something else. Okay? So let's put this to the test. Let's see if it works. Let's see if it, let's see if it works. So compile. Everything should be fine. Then when we run this, okay, so our first variation is integers. In this case, I'm going to put a 2. 2 sounds like a good choice. Our second variation is characters. We can put a W. And we can see right here that that worked exactly like it should. And our third variation should be variation 3 instead of variation 2 is strings. And we're just going to type milk. And so we should get milk. End of program. And so in all of these cases, that's how the switch works. That's what the switch does when it works. Let's look at how the switch goes. Let's look at how the switch goes when our user screws up. Okay, so our first one with these integers, I'm just going to type in 89. That's not one of our choices, but I'm going to type it anyways because I'm cantankerous. We see that's an invalid choice, and with the variation 2, maybe a capital W. This one is going to be a valid choice because we have that as one of our cases, but I want you to see it anyways. We had a lowercase w before, now we'll do a capital W. That still works. And with strings, I'm going to type soda. Not one of our choices. That's okay. It'll tell us it's an invalid choice, and that's that default case kicking in. We want the default case there to catch errors, even if you know for a fact that none of your even if you know for a fact that there is no possible way for an error to occur. Put the default case in there anyways, because that'll mean that if something changes, if someone comes along and screws up your program, if you come along and screw up your program, you have a way of figuring it out. That's what the default case is for. That's what the else statement is for. That's what all of the fail-safes that we've been talking about. These are things to make sure that if someone makes a mistake, including if you make a mistake, someone is able to, that you will be able to, with a little bit of work, figure out exactly what that mistake was. Now with the switch statement, as you use it, this is most useful when you're having the user selecting between or from a series of known discrete options. One way that we're going to use this is like a menu or like an options thing. The other way that we're going to look at this, one of the other ways that we're going to look at this here in a couple of days, is I'm going to have you write a program that converts using a switch between Morse code and English. That's not going to be too bad. It's going to be a lot of typing, but it won't be too bad. Now the switch statement, though, is not very useful at all for testing ranges or inequality or particularly complex conditions. That's one of the downfalls of the switch statements. It's not very useful for that. And the big thing perhaps that you should remember is that every switch statement can be turned into an if, else, if, and else block. Every single one of the switch statements that you could possibly write can be turned into an if, and else block. However, it's important to note that only some of the if, else, if, and else blocks can be turned into switch statements. That is to say, only the ones where they're testing a couple of discrete, separate options. Okay. When we come back, I'm going to show you real briefly the ternary operator, which is an alternate means of writing an if statement. And when we're done with that, we'll do some wrap up. Then you'll be free to read the textbook and go through the code samples. I'll see you in a second.